Hello students, I am going to demonstrate Young's modulus of the material of the beam by non-uniform bending method. So the same Young's modulus can be done by uniform bending method also, but right now I am going to demonstrate by non-uniform bending method how Young's modulus of the material can be determined. That means elasticity of the material can be determined. The apparatus required is, here you can see traveling microscope, and the material for which we are going to find out the Young's modulus is wooden material that is being taken in the form of beam. Though it is a meter scale, we won't call as a scale here, we will consider this as a beam. And you have two knife edges which has to be used to stand as to have for a supporting purpose. These knife edges have been used. Without these knife edges, this beam may not be able to support. So for that reason, two knife edges have been used. So you have to place this knife edge at one particular distance called 20 centimeter on one side. The same distance has to be maintained on the other side too. And then at the center part, so I told you this is 1 meter long, so 50 will be the center part. At the center part, pin has to be fixed either using wax or it can be tightly wind. And then you can use this tag for holding the dead load. So this is about the apparatus arrangement. Now you can see the pin which has been fixed at the center of the beam very clearly, whose pointed edge is facing upwards, and the tag is also wound on the same point of the beam in order to insert this dead load. Now I am going to demonstrate the traveling microscope. This is traveling microscope apparatus, and you have two scales in this traveling microscope. One is horizontal scale, the other one is vertical scale. In horizontal scale, you have main scale and vernier scale. Similarly, in the vertical scale, you have main scale and vernier scale. And there are so many screws are provided here for adjustment purpose. So this is tangential screw for horizontal scale, which can, by releasing this screw, you can move widely left and right. And similarly, the screw which is kept at the back side of the vertical scale, by releasing this screw, you can move widely up and down. By tightening this screw, if you look into carefully while adjusting this side screw, you can see the minute movement in the horizontal scale. I don't know whether you can able to notice or not. Very minute adjustment. By tightening this screw, the horizontal scale will move very minutely. Okay. The same thing, if I release and then operate, no, there won't be any movement in the horizontal scale. Then what is the usage of releasing and rotating the screw? If the screw has been come very close to this point, but the experiment has not been completed, but you are in need of rotating this screw, means you can release this and then move widely in this direction and have much gap for rotation, and then you tighten the screw and then proceed in the same point where you have stopped. For that purpose, this adjustment is helpful. And next is on the vertical scale, when you tighten the screw which is at the back, that is this screw. By tightening this screw and adjusting the screw which is at the top, you can move minute movement on the vertical scale. It is moved very minutely. Can you able to notice the minute movement on the vertical scale? But when I release and move, that does not happen. But what is the purpose of releasing and moving? See, now the screw, you can see only very small gap is there. So when I release, there won't be any change in your reading. Therefore, when there is a movement in this vertical scale only, there will be a change in the reading. So when I release and then rotate, there won't be any movement at all. Therefore, I can have much gap on the in the screw, so that I can continue the experiment from the place where I have stopped when you are in the halfway through. So how to take the readings here is the arrow mark in the horizontal scale, the arrow mark where it is coinciding with the main scale reading, that is your MSR. The arrow mark on the vernier scale where it is coinciding with the main scale is said to be MSR reading. That is how you will be noting down the MSR reading. In this here it has been found to be, you can use a reading lens. So it is around 5.75. It is coinciding at the 5.75. So you can take MSR as 5.75, and there are 50 divisions on the vernier scale. So arrow is 0. 0.1 no, that is 10, 0.2 is 20, 0.3 is 30, 0.4 is 40, 0.5 is 50. So there are 50 divisions in the vernier scale. So among 50 division, one will be exactly coincide with the main scale reading. Which division is coinciding with the main scale reading, you have to see. So sometimes 0 may be coincided. So if it is so, your vernier scale coincidence is 0. Or from there, 1 is coinciding, 2 is coinciding, or 3 or 4, which is coinciding. Where it is coinciding is not required. Which is coinciding, you have to notice down. So by notifying which division is coinciding with the main scale reading, that division is your vernier scale coincident. So where arrow mark is coinciding is your main scale reading. Among 50 division which is coinciding with the main scale reading is your vernier scale coincidence. So that is how you will be noting down the readings in the horizontal scale. Coming to vertical scale, the same way you can see where the arrow mark is coinciding, that is your main scale reading. Where arrow mark is coinciding with the main scale, that is your main scale reading. Among 50 division, here also you can see 1.62 like that. Starting 1 is 10, 2 is 20, 3 is 30, 40, 50. There are 50 divisions are there. So among 50 divisions, which is coinciding, that is your vernier scale coincident. Where arrow is coinciding is with the main scale, is a main scale reading. Among 50 division which is coinciding is said to be vernier scale coincident. So you have to see whether 0 is coinciding with the main scale, or 1 is coinciding, or 2 is coinciding, or 3. Suppose if 6 is coinciding, 6th division is coinciding with the main scale reading, exactly means 6 is your vernier scale coincidence. And arrow mark, suppose if it is lying between two readings, 7.5 and 7.6, it is found between 7.5 and 7.6 your arrow, then whichever is crossed, that only you should take. Unless and until it touches the next reading, you have to take the reading which is crossed. So that is how you have to note down the main scale reading. Here in traveling microscope, you are very much clear about two scales, which is horizontal scale and vertical scale. Apart from that, you have eyepiece. In that you have horizontal crosswire and vertical crosswire, and this is how you can do zooming. As I said earlier, one knife edge is fixed at 20 cm and the same distance has to be maintained on the other side also. So by keeping one knife edge at 20 cm from this side and 20 cm on the other side, the distance between the knife edges will be totally 100 cm. This side is 20 and this side is 20. Therefore, distance between the knife edges 60 cm. That has to be noted as L in our tabular column. L is equal to 60 cm, which is distance between the two knife edges. And now we have to focus the tip of the pin by adjusting this traveling microscope front and back and using this zooming lens. Yes. So you will be getting an inverted image here. So how it has been appeared on the scale, on the beam, is the pointing edge is facing upwards. So when you look into this travelling microscope, so by adjusting this top screw, I am making this tip should be coincide with that of the horizontal cross wire. So I tightened this screw, and then by adjusting this, I made the tip is exactly coincide with that of the horizontal cross wire. So the pin is pointed on the upwards. So after focusing into while looking into the travelling microscope, when I focus this pin to be exactly coincide with that of the horizontal cross wire, you can see the inverted image of the pin. So it is being pointed upwards, but when you look into the travelling microscope, the pointed end will be downwards. So if this is the horizontal cross wire, we have to adjust this tangential screw and make this tip to be coincide with that of the horizontal screw. See, if this is the tip has been fixed in this manner in the beam, but when we view through the travelling microscope, it has been inverted image. You can view in this manner. So the tip has been focusing downwards. So this has to be coincide exactly with that of the horizontal cross wire. That is how it has been made in this travelling microscope. The slotted weight dead load, the dead load is inserted at the center, and that should not be shaped. It is made still by holding like this. And then for this dead load, the tip has to be focused, and then it has to be coincided with that of the horizontal cross wire. The tip of the needle pin can be moved up and down. So what we require is the tip has to be exactly coincide with the horizontal cross wire for that particular load. So we'll start with the dead load. So for the dead load, the tip has to be coincide with the horizontal cross wire. Then by adding the slotted weights, this is what is called as slotted weights, and whose value is 50 grams. By inserting the slotted weight, you can observe the tip will be moved from the coincidence position. By adjusting this screw, once again you have to make the tip has to be coincided with the horizontal cross wire. For the dead load, after coinciding the tip with that of the horizontal cross wire, what is the reading in the vertical scale? You have to note down. The reason for noting down the vertical scale is you are doing only up and down movement, not the left and right movement. That is why you have to note down the readings only in the vertical scale, not in the horizontal scale. So you are making the tip to be coincide with the horizontal cross wire by adjusting this top screw, that is using the vertical scale only. That is why you are noting down the readings only in the vertical scale, not in the horizontal scale. So for the dead load, after coinciding with the tip, the horizontal cross wire, what is the main scale reading and vernier scale coincidence will be noting down. For the dead load, after coinciding the pin tip with the vertical horizontal cross wire, now I am looking into the reading on the vertical scale. So where arrow is coinciding, so you can clearly view using a lens, which is 11.05 and 1. Between 11.05 and 1, the arrow is coinciding. Since it has been crossed 11.05, it has not been touched with 11.1. So I am considering 11.05 is a main scale reading. So that has to be tabulated in the loading column for dead load. And among 50 divisions, which is coinciding, that is your VC. So when you look into this, you can see 14th division is exactly coinciding with that of the main scale reading. Therefore 14 is our VC. So in that way the experiment is repeated for loading the various slotted weights. So now I noted down this main scale reading and vernier scale coincidence in the loading tabular column. For the dead load, the main scale reading is noted to be 11.05 and vernier scale coincidence is 14. That has to be noted. And then while adding plus 50 slotted weight to this, now your load is W plus 50. So when I add load W plus 50, The verniers, the tip of the pin which is already coincide with the horizontal crosswire, by adding the load, the tip. So now 50 grams is added here. This is slotted weight 50 grams. So I added to the dead load. Now our load is W plus 50. Dead load is W. Now we added 50 grams here. So W plus 50. So for dead load, we already coincided the tip of the pin with that of the horizontal crosswire in this eyepiece. By adding the load, what happened? That coinciding position will be disturbed. It will not be there in that, the tip will not be there in the coinciding position. So therefore it has been moved. So by adjusting this screw, we have to make the tip of the pin to be coincide once again with that of the horizontal crosswire. So before noting down reading, ensure that the tip has to be coincide with the horizontal reading, horizontal crosswire by adjusting this screw. So for W plus 50, the tip has to be coincided with that of the horizontal crosswire. So after adjusting that, we have to note down the readings from the vertical scale, where the arrow is coinciding with the main scale is your main scale reading, and among 50 division which is coinciding with that of the main scale is vernier scale coincidence. So now another 50 grams slotted weight has to be added. So while adding, now the load is W plus 100. While adding load, as earlier, the tip of the pin which is already coincided for W plus 50 will be get disturbed by adding another 50 grams. So now by adjusting this screw, the tip of the pin has to be coincide with that of the horizontal crosswire. So while doing so, there will be change in the readings. That reading has to be noted down and has to be tabulated in W plus 100 MSR as well as VC. And the experiment is repeated for adding another 50 grams. So now the load is W plus 50, and before entering the reading, the tip has to be coincide with that of the horizontal crosswire, and the reading has to be tabulated in this tabular column. And then add, likewise, it has to be loaded till it reaches to W plus 250. So now your load is W plus 250. For that W plus 250, when the tip is coincide with that of the horizontal crosswire, by adjusting this screw, note down the main scale reading and vernier scale coincidence from the vertical scale and note it down in the tabular column. So while loading, you will be noting down from top to bottom, and unloading you have to note down from bottom to top. So for loading, W plus 250 is the final reading. For unloading, W plus 250 is the first reading. Therefore, this reading alone you can copy here. So the unloading first reading is W plus 250. For loading, last reading is W plus 250. Therefore, that reading alone copy in this. By adding load for every time 50 grams, you have to tabulate the readings in this MSR and VC. So in loading, W plus 250 is the final reading, and in unloading, W plus 250 is the first reading. So in loading, you will be noting down from top to bottom. For unloading, you have to note from bottom to top. Adding load is loading, removing load is unloading. So W plus 250 reading alone you can copy in unloading column, MSR, VC. Then you have to remove 50 grams from it. So from 250, if we remove 50 grams, what happened? It is now W plus 200. So while removing also, the tip of the pin which is coincide with that of the horizontal crosswire will get disturbed. Then it has to be coincide by adjusting this screw, and after ensuring the tip is coincided with that of the horizontal screw, you have to note down the readings from the vertical scale, main scale reading and vernier scale coincident. For W plus 200, unloading reading will be noted in this point. What is MSR and VC from W plus 200. So likewise, while removing 50 grams, it will be W plus 150. So that reading will be noted down here. So each and every time, before noting down the reading, ensure that the tip is coincide with that of the horizontal crosswire. In that, like that, you have to complete till it reaches to dead load. You have started with dead load and end up with dead load. See, while removing the dead. So keep on removing. Every time when I remove 50 grams, there will be disturbance in the coinciding position. Make it coincide, then note down the readings. Like that, every time remove 50 grams from it and then note down the readings. So now your load is dead load. So we started with dead load and we are ending up with dead load. For dead load, what is the reading you have to note down? Before that, the tip of the pin has to be coincide with that of the horizontal crosswire. So for dead load, what is the main scale reading and vernier scale coincidence? You have to note down. The least count for the travelling microscope is 0.001 centimeter. To calculate the total reading, MSR plus VC into LC. MSR reading you have to note down from this column, and VC, what is the vernier scale coincidence, that has to be multiplied with the least count, then that should be added with main scale reading. That is how you will be calculating the total reading, MSR plus VC into LC. So you have to calculate the total reading for loading and calculate total reading for unloading. Once you calculated the total reading for loading and unloading, find the mean value. Adding the total reading from loading and unloading and divide by 2 will be getting the mean value. So in that way you will be completing this column. So depression for load M. How to calculate the depression for the load M? M is what we assigning. Suppose if I assign 50 grams for the M, the difference between W and W plus 50 is 50 grams. Corresponding W mean reading and corresponding W plus 150 reading, you have to 50 reading, you find the difference. Find the difference between these two, find the difference between these two, find the difference between these two, and find the difference between these two. That is between 1 and 2, difference is 50. The corresponding readings, if you find what it is, note down. And from W plus 50 and W plus 100, the difference is 50 grams. The corresponding mean values, you find the difference and write here. So in that way, you find the difference between 1 and 2, 2 and 3, 3 and 4, 4 and 5, complete here. When M is 50. It is not constant. Even you can assign M is 100. Even you can assign M is 100. If it is 100, the difference between 1 and 3, that is W and W plus 100, difference is 100. So what is the M mean value for W and what is the mean value for W plus 100? Find the difference between these two and write it here. So that is for 100. Similarly, 1 and 3, 2 and 4, 4 and 6 if M is 100. But in our class we are going to do with 1 and 2, 2 and 3, 3 and 4, 4 and 5. That means M is 50 grams. M is equal to 50 grams. In that way you can find out the depression. So what is the depression? So we added the load at the center of the beam. So by adding load at the center of the beam, there will be a depression formed. So it is being bent. It will be bent in this way. So while adding 50 grams each and every time, there will be an arc formed. So arc will be formed. The depression is like this. Depression is formed. There will be a bend in this beam. It won't be this much bend. For make you clear, I am showing this much bend. See, this is by adding load, the depression will be formed. So when we add each and every time 50 grams, the arc, the depression seems to be like arc. So every time while adding load, when the arc is formed, when we collect those arc and form a circle, that will not be complete circle. So that is how this is said to be non-uniform bending. Whereas in uniform bending, that arc formed by elevation will complete as a circle. That is why that is said to be what is called as uniform bending. Here depression will be formed, there elevation will be formed. So this is the difference between uniform and non-uniform bending. So while completing this tabular column, you have to remove this load and find the breadth of the beam using vernier caliper and thickness using screw gauge. You can take the beam out. And the basic instrumentation has been given a separate video, so you should know how to use the screw gauge. So this is the pitch scale and this is head scale. You have to fix the beam, you have to find the thickness of the beam. And give 2 clicks on, keeping the object which has to be measured in between these two jaws, and give 2 clicks on. So what is the pitch scale reading? You can see 5 is the pitch scale reading. There are 100 divisions. and which division is coinciding is 97. 97 is coinciding, so that has to be noted down in your tabular column. Determination of the thickness of the beam using pitch scale reading is PSR is 5 and head scale coincidence is 96, and the same is being repeated at different position at 5 different position. When you look into the reading, there won't be change in the PSR, that is pitch scale reading will remain same, only there will be change in the head scale coincidence. So I can see 94 here, in another case 95, and then 94, 91. So that is how we can complete the thickness of the beam using screw gauge. PSR plus HSC into LC. So find out the error. In our case the error is 0 in this instrument, but there may be positive error and negative error will also be there. So learn basic instruments and find out how to calculate the error from the given instrument. So since the error is 0, PSR plus HSC into LC. HSC is 96. Least count for screw gauge is 0.01 millimeter. So HSC should multiply it with the least count and add with PSR, complete this corrected reading. So the mean value of this will be your thickness of the beam using screw gauge. So after completing the thickness of the beam using screw gauge, we have to go for breadth of the beam using vernier caliper. So breadth of the beam, see between these two jaws, the objects to be measured has to be placed. And what is the main scale reading and vernier scale coincident? So here, which is the main scale reading where the 0 is coinciding, is your main scale reading. So which is in our case just 2.5. So main scale reading is 2.5 and vernier scale coincidence is 7. So main scale reading 2.5 and vernier scale coincidence is 7. So where this 0 is coinciding is main scale reading. Among this division, 10 divisions are there. Among this, which is coinciding is your vernier scale coincidence. So the procedure is repeated by keeping this jaw at 5 different places in the beam. Calculate the main scale reading, what you observe for main scale and vernier scale coincidence. For making this tight, you can use this screw and then so once if it is adjusted, it has to be fixed like this. So fix it and then note down the main scale reading and vernier scale coincidence. So in that way, complete the 5 readings in the main scale reading and vernier scale coincidence. So vernier caliper and all the instruments in our lab, error is 0 and least count is 0.01 centimeter. For screw gauge it is millimeter and for vernier caliper it is in centimeter. So MSR plus VC into LC is your observed reading. Corrected reading is depending upon the error. Since the error is 0, the observed reading will be repeated here. Observed reading and corrected reading will be the same if the error is 0. And when coming to screw gauge, depending upon the error, correction has to be made. Suppose if your error is, example I am telling, what I have used, I got it as 0. But if you happen to get plus 3 is your error, means minus 3 will be your correction. That will be, it is given in millimeter. Therefore, you have to multiply with 0.01 into 3 will be 0.03 millimeter. If it is plus, this is minus. Error is plus means correction will be minus. So in that way you have to find the error and correction. So now coming to after completing this vernier caliper readings, mean value of the last column you will be noting down as the B, that is breadth of the beam using vernier caliper. So coming to the calculation part. So E is equal to mgl cube by 4bd cube by Newton per meter square is the formula for Young's modulus. M can be substituted as 50 grams because we have done the difference in the last column as between 1 and 2. 2 and 3, 3 and 4, 4 and 5, 5 and 6. Here we have done now. So between 1 and 2, the difference is 50. So we are assigned M is 50 grams. Therefore, M will be substituted as 50 grams. So M is equal to 50 into 10 power minus 3 kg. G, 9.8 meter per second square, acceleration due to gravity. Mg, then what is there? L cube. L, what is that? What is the L? I said initially distance between the knife edges, which is 60 centimeter. 60 into 10 power minus 2 meter. And then breadth of the beam can be calculated from the tabular column, the mean value from the tabular column of the vernier caliper. Breadth of the beam can be calculated from the vernier caliper. B is so much into 10 power minus 2 meter, which is around 2.5 into 10 power minus 2 meter, and the thickness is being calculated from the screw gauge tabular column, which is around 5.9 into 10 power minus 3 meter, and Y, the depression produced, the last column, mean value is Y, so much value into 10 power minus 2, so that you have to substitute here. After substitution, get the answer in terms of 10 power 10 Newton per meter square. So this is how Young's modulus of the material of the beam can be calculated. We have done for wooden material. So material to material Young's modulus will change. Elasticity will change. You can do it for steel or iron or glass material. For any material you can do it. So what we have done right now in the demonstration is for the wooden material. For the wooden material it is around 1 into 10 power 10 Newton per meter square. You won't be getting exact the answer. So it may be plus or minus values. That doesn't matter. You should learn to do the experiment promptly rather than arriving at the answer. But if you do promptly, definitely you will arrive the answer in a correct manner. The practical application of this experiment is, without knowing the material study, you can't use that material for the particular usage. Suppose if you want to construct the building, the material what we are using, whether it can withstand the multi-storied building or single-storied building, for that you have to study the material characteristics. And then this the same experiment can also be utilized in the construction of bridges. While constructing bridges, you can see that whether this much particular load of vehicle can travel on that bridge, because the bridge is being constructed in such a way that it can withstand this much load. So whether that much load is being transporting to that side, it has to be monitored. Otherwise, it will be destroyed very quickly. So before construction, for anything or any material, whenever it is being used for any particular usage, the characteristics and material study is very, very essential. So one such study is Young's modulus, the elasticity of the material. So this is, we have done in a small scale manner in industry, and in other places they would have been do in the large scale manner. Hope you all understood about the Young's modulus of the material of the beam by non-uniform bending method. So the practical usage also will have been known by this time. Okay, thank you.